Okay, so today we're going to be looking at the Bohr models. And basically, the Bohr model is just a two-dimensional representation of an atom. In real life, atoms are 3Ds. The electrons are in electron clouds. It's not as clear cut as these nice little circles, but that's all messy and it's difficult when you're trying to figure things out about them and calculate things with them. And so the Bohr model is really a simplification designed in order for us to understand these things. It also really works best with only the first 18 elements of the periodic table. This has to do with the way atoms store electrons in different orbitals, which we'll have to look at later in chemistry, but for right now, we're just talking about energy shelves, or these energy shales, sometimes they're called, that is different levels, if you think about it that way, of keeping electrons in an atom. So we're going to look at a couple of things and how to make our own. This over here, by the way, is a rough representation of one that's empty. This is like your starting place for almost all Bohr atoms. Notice it has a nucleus that has protons and neutrons, and you would place the electrons in the proper orbitals as you go around. Okay, let's get started. The first thing to keep in mind is figuring out the number of electrons. When we do a Bohr model, we usually want to start with a neutral atom. That's what is on all of the periodic table, and so for that we're going to get the electrons from the atomic number because it's going to be equal to the protons, and that'll give you an idea of how many it should have to start with. The other thing we need to know from the periodic table is the energy level. And we're going to get that as well because remember the periods, or those rows, if you don't know to call them periods yet, will indicate how many of these little energy levels we need to draw. So for like hydrogen and helium, they only have one, and they're on the first line. Get to lithium and some of those on the second one though, they'll have two, and we're going to go all the way to 18, so you'll get to those that have three. And then it's just a matter of filling things in for them. Okay? So let's go ahead and jump in and make our first Bohr model. First thing every element needs, no matter which element you're going to do, is a nucleus. So remember, your nucleus is just the inner core that's filled with protons and neutrons. Now we need to define what element we're going to do by figuring out the number of protons. I say we're going to do a very common one. Let's do oxygen. So if you go to the periodic table, you can find oxygen, and once you find it, you need to look at that cell to figure some things out first. Some of the things you need to know are the atomic number. The atomic number is simply the number of protons, okay? And so here's our atomic number for oxygen. That means it has 8 protons. But you also need this number, the atomic mass. Remember, the mass is made of protons and neutrons added together. So we're going to round this up to the nearest number, or round it to the nearest whole number, depending on which way we need to go, and 16 would be best. So you take 16, you subtract the number of protons, and you only have the number of neutrons left. So 16 minus 8 is 8. So we know oxygen has 8 protons and 8 neutrons. So now we can fill in that little spot. So let's go back. We now have 8 protons, 8 neutrons. The next thing we need to know is the number of energy shales. Well, you learn that by its placement on the periodic table. So if you look at the periodic table, each row, and it has 7 of them, represents another energy shelf. So with oxygen, it's on the second period, which is a row, is what we call a row, is a period. And so that means it's going to have 2 energy shelves, or energy shales, where electrons go. So now we know we can draw 2 electron shelves. So let's go ahead and draw those. Let's draw them in green. What do you say? So there's 1, and there's 2. So it's already coming together pretty good. No, they're not perfect, but that's okay. Remember, this is just a representation for us so we can keep straight where everything goes. Now we could look on the periodic table, but we already have the correct number of protons, and so if we're doing a neutral atom, if you have 8 positive things, you have to have 8 negative things. And so that means we're going to have 8 electrons. But before you go and start throwing them just 8 electrons anywhere on these rings, you need to understand how many can go on each level, because each level can only hold a certain number. And if you remember correctly, I showed you that in a chart a while back that looked like this. So this chart shows our energy levels and how many is the maximum number of electrons that can go onto it. Something else you need to know is every element is going to fill up their first level first before they start moving on to the next level. So you have to fill up 1 before you go to 2, before you go to 3, and so forth. We're only going to be dealing with the first 3 elements. I'm sorry, the first 18 elements. So if you notice, we're only going to need to the 3rd shelf for right now. So we need to know the first one can only hold 2, the second can only hold 8, and the third can actually hold up to 18. We'll get more into why these increase and are different a little bit later in the unit. Now then, let's go back to our Bohr model of oxygen, and let's go ahead and start to put in blue those 8 electrons, because we're going to have 8 electrons, we have 8 protons. So this first energy shelf, it can only hold 2. So I'm going to put 1 and 2. Let's see if I can actually fill that with blue too. Yep. So that's 2 in the first energy level. Now, if you remember though, I need 8. So 8 minus 2 means I have 6 left. But I had to fill this energy level to its max before I could start to put any in this next energy shell. As I start to put these, I'm going to put them in a nice little order. I'm going to start by putting 1 on each side, and after I have all 4 sides covered, I'm going to start to pair them. If you start to do this now, it will help you greatly when you get to the Bohr or to the Lewis dot diagram, because what we essentially did was we created electron pairs, and that's what you see there, and we see where there's open things. Now, remember, this orbital can take 8 total electrons. So something else you can sometimes do is say, hey, that means that I had 2 openings still available in this. I had 6 in the valence shell. And that's really one of our big checks and one of the things why it's important. You have this valence shell, that's the outermost shell of an electron, or of an atom, where electrons go. And it tells you how many it can hold total, how many are missing, how many it already has. Gives you a good idea of a lot of different things. So this is how you do a Bohr model of an atom. One more thing real quick is let's go ahead and check to make sure it's right. You can do that by looking at that valence shell. We have 1, 2, 3, 4, 5, 6 electrons in oxygen's valence shell. Well, if you look at the columns where oxygen goes, notice that oxygen is right here in this column. Well, if you remember this diagram, oxygen being right here is in 6A, meaning it should have 6 valence shell electrons. And it's just a quick way to check. That might help. I don't know.